Hey there, ladies and gentlemen. Welcome to the Burma Nation. We are talking today. I know it's hard to see because my face is in the way. I'll move it down. We are talking about simplifying radical expressions. This is lesson 10.2. It's day 1 of 10.2. So we're going to talk about just one property, and then the next video will be about the next step in 10.2. So we're talking about the product property of square roots. So here's an example. If I were to have a math problem inside the radicand of a square root problem, I would have a square root of a 4 times a 9 could be looked at as a square root of 4 times the square root of 9, which could be looked at as the square root of 4 is 2 and the square root of 9 is 3. Now, another way of thinking about that is also if I were just to take and do the math on the inside, it would become the square root of 36, which is just equal to 6. So this is one way for us to think about this math problem, and we're going to do our best to try to simplify our radical expressions. So you're going to want to have a calculator. You're also going to want to have your previous knowledge of what perfect squares are. Your perfect squares are like 4, 9, 16, 25, etc., etc. So then remember, we do those things by doing 2 times 2, 3 times 3, 4 times 4, 5 times 5, and that's how we are going to be thinking about this radical stuff. And I know it's not like radical, like, dude, radical. It's more like radical, math geek stuff. All right, so here's our first problem. We're going to take this, the square root of 52, and we are going to break it down. And the way that I like to think about it is breaking it down into a perfect square and whatever else is left over. So I try to take the biggest perfect square that I know and check out what I can divide out of there. So I'm going to start with numbers that are less than 25, or 25 or less, because I know 25 can't go into it. So I'm going to use my trusty calculator, and I'm going to take 52 and divide it by 16 and realize, of course, that that does not work. And I'll check my next one of 9. I also know 9 doesn't work, so I'm going to guess 4. 4 might work, 52 divided by 4. And it does work, that's nice. So if I break this down into the square root of a 4 times the square root of 13, I know that the square root of 4 is actually just a 2. And the square root of 13 is, it's not a perfect square, and it doesn't break down any further. So my answer in a simplified form is just 2 root 13. And that is all we are going to do. So we're just trying to find numbers that are perfect squares that we can divide out of these not so nice perfect squares to simplify. So that's part of the process here, folks. I hope you think that's pretty simple, because here's another one. So we have the square root of a 2 times the square root of 24. Now, me personally, I like to take that and multiply it to make the square root of 48. And now this is exactly like the problem that we had before. So if I break this down into numbers that we know, 48, can we do that one divided by a 16? Yeah. So I trust my calculator to help me out here. I have a square root of a 16 times the square root of 3. Because the square root of 16 is 4, I have a 4 root 3, because square root of 3 can't break down any further. So we're going to just break things down to a level that makes more sense. Now, I could have thought about this problem in a different way. I could have had my square root of 2 and then breaking down this 24 into another number like 8 and 3, and then multiplied these two numbers together to make a 16, so that I would have a 16 root 3, square root of 16 and square root of 3 to also get down to a 4 root 3. That's just another way that we could think about it. I think that way is a little bit more complicated, because then you're trying to multiply to make things a nice perfect square. Whereas if we just divide out, I think that's a little bit easier thinking for me. Now our next thinking has to be about just square roots with exponents on the inside. So if I have the square root of something like x to the second power, that is the answer of an absolute value of x. Now, because we are dealing with absolute value, that means we're looking for only the positive number. And we need the positive number to happen because it's a square root. And I can't have the square root of a negative number and be in my real number system. So that's why we have to make sure that we have an absolute value of it. So what we're going to do is we're going to break down these things, and break down like a square root of x to the third would be an x to the second times an x. the square root of x to the second is equal to the absolute value of just an x. So then we have this left over for our answer. So you're more or less taking, for the square roots of exponents, you're taking the number for your exponent and dividing it by 2. Now, what I think is the easiest way to do this is if we had the square root of x to the 7th, is that I would break this into the square root of x to the 6th, my largest even number, times the square root of x to the 1st, and then I would just know that this breaks down into an absolute value of x to the 3rd, and then I would just bring my square root of x down. So if you just break down or subtract 1 out of your exponent to make that exponent an even number, and then when you square root it, you're just going to basically divide it by 2. Because when we added those things together, like we did in chapter 7, it makes more sense. So let's see what our last problem looks like. Now you might want to write some of this stuff down as a good reference material, how to simplify things. And you'll notice hopefully a pattern with when we need the absolute value bars and when we do not. So as long as we have from an even number coming out, we will have ourselves the absolute value bars. All right, so check this out. Are you ready? Here's our very last problem. So we're first going to be looking at the 45, and then we will look at the a to the 4th, the b to the 5th, and the c to the 6th. Well, that became a really big 5. I'm going to erase that, make it smaller, so it doesn't look like it's different. And so what we are going to do here, folks, is we're going to basically look at each individual piece and simplify each individual piece. So things are going to come out of the radicand and things are going to stay inside based off of what they are. So a 45 can be broken down into a square root of 9 and a square root of 5. So my final answer is going to have the square root of 9 is 3, so I'm taking a 3 and bringing it to the outside. And the square root of 5 is still gross, so it stays on the inside. Now the next part we're looking at is the a to the 4th. A to the 4th is an even number, so it just comes out as a to the 2nd, and there's no a's left in. A b to the 5th turns into a b to the 4th and a b to the 1st in square root land. So a b is going to stay left on the inside, and a b to the 2nd, or b squared, comes out to the outside. And since c to the 6th is an even number, that just breaks down to a c to the 3rd, and that just comes to the outside, and there's nothing left on the inside. So you'll see how that worked out is that all of my even number exponents just got cut in half, and then the odd stuff was left on the inside. So this would be my official broken down answer, or the simplified answer of 45, a to the 4th, b to the 5th, c to the 6th. So we came out a 3, a to the 2nd, b to the 2nd, c to the 3rd, and left inside the square root was 5, and then b to the 1st. And that's how these problems work here, folks. And this is using just the product property. Our next video, our day 2 of lesson 10.2, will be about using the quotient property. All right, folks, this is the Berman Nation. We're signing off. Good luck. Have a wonderful day.